Hey everybody, it is Nathan Selove, and today's video is going to be a little bit different than usual. So some of you might know this because I have discussed it on my YouTube channel before, but I actually have a political podcast called The Perspectrum, in which myself and a good friend of mine break down the politics of the week and discuss our own political opinions regarding politics. And this week, we had a segment in which we talked about the vaccine from a scientific perspective, and we actually had my father on the pod to discuss it. Many of you are probably familiar with my father, who has come in on the You Might Be Autistic If videos, on several of those, but he is also a retired professor of anatomy and physiology. So he's actually an expert on this overall area. So he came in and he discussed the science behind the vaccine, and he tried to encourage people to take it as soon as it becomes available to them. And because I've talked about vaccines on this particular YouTube channel, I thought it would be appropriate to go ahead and share the audio of that segment with you all, and hopefully try to encourage you all from a scientific standpoint that taking the vaccine and trying to get out of this pandemic as quickly as possible should be a priority. So, little quick warning though, this particular podcast does contain some vulgar language, not a lot, but some, so I definitely would say viewer discretion is advised. And if you are interested in more episodes of it, you can find us on Spotify, you can find us on Apple Pod, and you can also find us on Podbean. Again, the name is The Perspectrum, and I will leave links to the podcast below. Let's put aside the politics for a little bit, and I want to specifically focus on the science behind the vaccine. So, from a lot of people's understanding, as well as my own understanding of how vaccines work, basically, you are being injected with either a weakened version or an inactive version of a virus in order to, in essence, teach your immune system what that virus looks like, so it produces the right cells to attack the virus if it comes back into your body. And that's how you get immunized from vaccines. Would you say that that's an accurate description of how vaccines normally work?
That is essentially accurate until now.
So how
Because
exactly, how is this different?
This new approach to vaccines that we find in both of the vaccines that have been approved at this point, the Pfizer-BioNTech vaccine and the Moderna vaccine, these are a completely different approach. In this case, what you're injecting is not virus, it's not viral proteins, it's not killed virus. What you're injecting is actually entirely synthetic messenger RNA that codes for some proteins that are found on the surface of these viruses. The spike protein is one of the main ones, although there's a few others, the N protein. These are the way that your body recognizes the virus as being foreign. And so in this case, it ends up being possible to teach your cells to attack the virus without having to run any risk whatsoever of someone actually getting the virus, even a very mild form, from a weakened version of it. As I said, it's an entirely new approach. Now, scientists have been working on this for a little over a decade, and it's been slow. It's been delayed partly because there wasn't this overwhelming need like the pandemic that we have now that has caused the money gates to open.
Yeah.
When the money gates open, you can accomplish amazing things in scientific research, and we're seeing some amazing things now. But let me just back up a little bit and remind you of what RNA is, especially what messenger RNA is, so that people will be able to understand what's going on with these shots and why it's so different. You probably remember from high school.
Yeah, I definitely do.
This is one of the stock joke phrases that I used throughout my career. Whenever I said in class, "as you remember from high school," I knew perfectly well that nobody remembers a damn thing that they learned in high school. Except me.
Show off.
Little autistic me still remembers every word my biology teacher in high school ever said. Anyway, so when people think about genetic material, they normally think about DNA, which is found in the nucleus, and it contains our genetic code. And that DNA is used to make RNA, RNA that carries a message from the nucleus into the cytosol of the cell, where it comes upon ribosomes that read the genetic code off the RNA and use it to make proteins. And those proteins end up being the structural basis for parts of your cell, but also for viral particles, and also functional parts, the enzymes that regulate metabolism of living things. So some viruses are made out of DNA, some viruses are made out of RNA. And this particular virus, the coronavirus, is an RNA virus. So when it gets into a cell, it takes over your cellular machinery to make proteins to build its own body instead of the things that you normally are building. That's how viruses work. It's one of the reasons that scientists sometimes have these arguments about whether to consider viruses alive or not alive, and why the phrase live virus versus killed virus is technically not correct, because they're not really alive in the first place. Although I'm actually one of those people that comes down on the side that I think viruses should be considered alive. I won't replay that whole debate, but it's an interesting one. With these viruses taking over your cellular machinery, eventually, once they fill your cell with copies of themselves, they go through what's called the lytic cycle, which breaks or lyses your cell. And then each of these escaped virus particles can create another generation by infecting neighboring cells. And all this cell death is what ends up making viruses such a problem in an infection. So what we're doing with this new approach to vaccines is actually injecting people with messenger RNA that has been coded to make specific viral proteins. There aren't the actual virus particles that would normally get the genetic material into your cells. Instead, that job is largely done mechanically by the needle itself when it's injecting you. When that needle enters your arm and it goes down into the muscle layer, it's important that this be in the muscles, because you don't want to put it in the skin, because the skin will just kind of slough off those are relatively short-lived cells anyway.
Yeah.
But by injecting it into the muscle, you actually end up getting these pieces of RNA. Now, the RNA isn't bare. It's been encapsulated with a little lipid capsule that's a little bit like a cell membrane, but much smaller. Those little particles end up getting inside of cells. Some of them get inside cells directly because the needle ends up leaving them there. Some of them may be incorporated into cells because the needle does some damage to some cells, and as those cells heal themselves, they sort of take in that lipid vesicle that contains the messenger RNA. And once that messenger RNA is inside the cell, it drifts over to a ribosome, starts causing the ribosome to read its code and build these proteins. And these proteins then, through the normal process of moving through the endoplasmic reticulum and the Golgi apparatus, eventually end up showing up on the surface of the cell. And because these are foreign proteins, they stimulate the immune cells to recognize them as foreign and start building an immune response. And in particular, it helps cause B cells to make antibodies specific to fighting those viral proteins. So when this happens initially in your first dose, you tend to get a fairly small immune response. When it happens in the second dose, because these are both 2-shot regimens, the immune system kind of realizes it. One of the problems with vaccines always is if a vaccine doesn't make you sick, your immune system might not take it seriously and might mount kind of a weak defense.
Yeah.
And a weak defense might leave you unprotected if you get exposed to the real thing.
Yeah.
That's why live virus, so-called live virus vaccines, or what we should call active virus vaccines, are usually more effective than the killed or inactive virus
But
vaccines.
they're also more brutal.
But they're dangerous.
Yeah.
People get sick.
Yeah, like the smallpox vaccine.
The smallpox vaccine was tough. When I got it as a kid, I was sick for a couple of weeks.
Yeah.
Most people got sick. At my school, when they gave the smallpox vaccine to everybody, we were all lined up in the hallway at school. And after we got that, they closed the school the next week because, people were going to be so sick that hardly anybody was going to go to school anyway. So,
Yeah.
yeah.
But that's part of what made it so effective, because basically your immune system is smart enough to know, wow, this hurt. This sucked. We don't want this again. We got to make sure that we have a resistance for this in the future.
Exactly. So there's another technique that's sometimes used with vaccines. Instead of giving someone a virus that is weakened or attenuated but can still infect, sometimes what they'll do is give the inactivated virus but with some other chemical added to it to sort of make the experience worse for your body so that your immune system takes it more seriously. This is called an adjuvant. So adjuvanted vaccines are designed specifically to make the whole experience a little bit more traumatic in a cellular sense so that your body takes it more seriously. Well, it turns out this new approach gives you a very strong immune response without being adjuvanted and without having to have a live virus. Having your cells taken over by this foreign messenger RNA that starts producing these foreign proteins, that's enough to cause, especially when it happens twice, because it's an initial and then a boost, in that 2-shot regimen. This is in vaccinology, it's sometimes called prime and then boost.
Yeah.
So this prime boost approach, people get sick. Most people, when they get that second shot, have fevers and headaches and feel bad for a day or sometimes 2.
But basically what you're saying, though, is you're not actually infected with the virus when you are feeling those symptoms, which means number one, you can't spread it to anybody else. And number two, you're not actually in any danger. Like the symptoms you're feeling, they might suck, but they're not necessarily your body being in danger, correct?
Right. What you're feeling is your body taking the vaccine very seriously and building an immune response that's going to function very effectively. And the effectiveness ratings that we're seeing on these from the research that's published on it now are like 94 and 95%. Just staggeringly effective. This is amazing. And this is not only great for the for this pandemic. This is great for the future too.
Yeah.
If a lot of times our flu vaccines are not particularly effective. When we get a 70% effective flu vaccine, we think of that as being pretty good. A lot of times they're down around 50 or 60% effective. If we can start having 95% effective flu vaccines by using this approach,
wow,
it's going to revolutionize flu.
Yeah. Well, you
This-
do that, I mean, so few people will be able to get the flu that it just won't spread.
It's if we could do this in a widespread way, we might be able to actually make a difference in flu strains. Now, I don't think that we're ever going to completely eliminate flu from the world, but I think it'll be within the possibility to quickly eliminate individual flu strains.
Very
And
quickly.
that and the quick, typically it takes about a year and a half from the time you figure out what you expect a flu to be that will be moving around the world till you have a vaccine effective. This new technique is going to let us have vaccines much faster.
Yeah.
This itself was incredibly fast. It went from genetic sequence to approved vaccine in, 10 months?
Yeah, something like that. Yeah, 10 months.
So that is amazing itself, but part of that was trying to figure out how to do this. It's going to be possible to go even faster than that for other vaccines in the future. And so future pandemics, we're going to have a new approach to really deal with it more effectively, and there will be future pandemic possibilities.
Yeah. So I think the bottom line that I want people to understand from this whole discussion is when you do get the vaccine, it will probably make you feel kind of crappy for a little bit, but that's okay. That is a part of that's a part of the process. That means it's working.
When you feel sick from your second shot, rejoice. That is exactly what you want to see.
Yeah. So, but the other thing is to say, not only does that mean it's working, you're not in danger from that. So I also want to make sure that we are reassuring anybody that might be concerned about that might have heard some conspiratorial nonsense about it. I want to reassure people from the point of view of an actual scientist here that as soon as you can get the vaccine, you absolutely should get it.
And if anybody is looking for more than this very short discussion, I realize you guys don't think of this as a short discussion. This one's a long one for you. If you want to hear a much more complex, deeper scientific analysis of this, like about 2.5 hours at a time, go to a podcast called This Week in Virology. I mentioned it last time I was on. Vincent Racaniello is the host, the main host of it. And they put out several episodes each week during the pandemic. And it will teach you more about virology. If you find the details of this interesting,
Yeah.
do yourself a favor. Actually learn about it, especially learn about it before you spread any bullshit that you find on the internet.
Yeah.
Get the truth first.
Yeah. The last thing that I want us to talk about is the mutation of the virus in the UK. There's definitely been a lot of global panic over this possibility of a mutated strain within the UK. I know that when I saw it, I went all Odysseus and I was like, okay, who opened up the bag of wins?
So could you read that headline that you were showing me yesterday?
Yeah, so this headline is from the Washington Post. It says, British officials identify coronavirus mutations, but significance remains unclear. So should I be crapping myself right now?
So that headline is an oxymoron.
Okay.
It makes no sense whatever. And the reason it makes no sense is because the word mutation is not correct to be using here. In the old days, when before we had genetic sequencing techniques, the way you noticed that there was a difference was by seeing a physical trait or a physiological trait that was different. That's what a mutation is. And early on, we figured out that many of those different physical traits, called phenotypes, actually originate from a genetic difference, a genetic variance. And so people initially started to think, oh, okay, there's this one-to-one correspondence between the change in phenotype, this mutation, and a genetic variance that causes it. But when genetic research progressed and we got the possibility of doing lots and lots of genetic sequencing, what we found out was that there are huge numbers of genetic variants, and very few of them ever lead to any actual different physical trait. So what was found was a genetic variant, not a mutation. Now, a genetic variant can be a mutation, but it isn't necessarily. And it's by no means clear that this one even is, which the headline actually says. It says, but significance remains unclear. If significance remains unclear, then it's not a mutation. If it was a mutation, the significance would be quite clear. It is possible for a genetic variant to end up being a mutation that could change something important like transmissibility, which is what people are so worried about. But that has not been the case before. There have been other genetic variants that have been found in coronavirus, and people initially thought that because they were fairly common in certain countries, that must mean that they were more easily transmitted. And on further analysis, it has always turned out to simply be founder effects.
Okay.
If a person with a particular variant happened to go to a super spreader event, that ended up being a lot of people getting it, and those people spread it to others. It was purely a stochastic event, a chance event. It's not because there was some important difference in that genetic variant. And, so maybe this genetic variant will be different than all the others for coronavirus and all the others that have come up with other viral illnesses.
But the primary reason why...
I doubt it.
So the primary reason then why the UK has found this and is discussing it is not necessarily because it's unique. It's because the UK is better at finding. This
is very important. It is not a coincidence that the UK is the country in the world that is doing the best job, doing the most genetic sequencing of any country in the world, and that is where this variant was found. It was found there because they're looking for it there.
Yeah.
Anthony Fauci said yesterday this variant is almost surely already in the U.S. We haven't seen it because we haven't done enough sequencing, but we're looking for it.
So I think the thing that people are probably most worried about is, could this variant have any effect on the effectiveness of the vaccine?
So let me start by saying it's possible that a variant could have an effect on how a vaccine works. However, it is not possible that this variant will have any effect on these vaccines, because these variants don't appear to have any effect on the spike proteins or the N proteins, and those are what these vaccines are based on. So, no, I do not foresee any effect on the currently available approved vaccines. It's something that will have to be looked at on the other vaccines that are coming up. I suspect it won't have any effect on those either. One of the things that you have to keep in mind with genetic variants is the vast majority of genetic variations have no effect on phenotype at all, because you can change a lot of single nucleotides. These are in the field, these are often called SNPs, which is an acronym, SNP, single nucleotide polymorphism.
Yeah.
So these single nucleotide polymorphisms means that there's just one nucleotide in the genetic sequence that is different, and the vast majority of the time when that happens, it ends up not actually substituting a different amino acid in the protein that's coded. And so they're totally invisible.
Yeah.
These variants can be useful for trying to figure out who infected whom, and that can be really important for contact tracing purposes. But in terms of the significance for how sick people get and vaccines, no, it's really not going to be any problem.
So
It's just a sensational headline from people who didn't understand.
So that's very good news. And the last thing that I want to say on this, on this entire segment about vaccines is there is finally a light at the end of the tunnel. I mean,
Oh, yeah.
it has been a shitty year, and COVID has been a global catastrophe. And I mean, it's still going to be a slow process to get out of the pandemic. At this point, it kind of feels like you're in the tunnel, both of your legs are broken, and the only way that you can get to that light is by crawling using your arms. But we can see the light. We see a goal. There is an end in sight. And for the first time, there really is legitimate hope.
There is. If you've ever actually walked through a long, dark tunnel, you get this analogy. But if you haven't, there's this tunnel I used to like to take my family to in Paw Paw, West Virginia. It's part of the C&O Canal. And the tunnel is long enough and it's curved so that when you're in it, you can't see out the ends. And so when you're walking along that towpath next to the canal, it is total darkness. And eventually, you're walking through and you're thinking, oh my God, am I ever going to get my way out of here? You eventually get around the corner enough that you can start to see the other opening that the light is coming through. And once you can see that light coming through, you can tell what direction you're going. You still can't see very much, but you can tell what direction you're going. You can tell about how much longer it's going to take. It's an incredible feeling of relief to get to that point. And that's how I feel now. This has been a long, dark tunnel, but this these vaccines and the other ones that should be coming along soon too, they show us where we're going. They reassure us that there really is an end to this, and it's not that far off. We are still in the tunnel. You still need to wear your masks. You still need to be careful. You still need to isolate. But it's not going to be forever.